people of the internet. Welcome to Constant Science. I am Don from Explosions Incorporated. Well, it's flu season, and that means a couple of things. The first thing it means is a lot of people are going to get sick by contracting the influenza virus, whichever strain is going around this year. And second, some of those people are actually going to die from the virus or from complications arising from the infection. Now, a couple of weeks ago, in my first video, or our first video, I guess, which was all about Ebola, I talked about the death rates of Ebola and the infection rates of Ebola, but we didn't really talk about viruses themselves. So seeing that it's flu season, I thought that's what I'd cover this week. So when a virus takes hold in your system, a couple of things happen. It starts reproducing and you start having symptoms that are identified with the disease that virus causes. How does this work? Well, it's actually pretty simple. A virus is tiny. It's really, really tiny. In some cases, 100 times smaller than the cells in your body. Well, it attacks a cell. And it could be a plant cell or an animal cell, or in some cases bacterial cells. It depends on what kind of virus it is. It attacks that cell by latching onto its cell membrane and injecting its own genetic code, DNA or RNA, into that cell, at which point that cell's own metabolism is hijacked because the virus itself, doesn't matter what shape it is, some are geometrical, some look like spiders, some of them are long kind of strands like the Ebola virus I used a picture of a couple of weeks ago. They are only a protein capsule surrounding genetic code, DNA or RNA. There are DNA viruses and RNA viruses and retroviruses, and they're cool, and I'll talk about them more in a second. They don't metabolize. They aren't really alive in the same way that most things we think of are alive. They have to use the metabolism of an existing cell to reproduce themselves. So they inject their own DNA or RNA, and it happens differently depending on what kind of virus it is, but the upshot is this. It hijacks the cellular processes and the organelles that replicate the DNA for the cell itself to replicate its own genetic code and then build the protein capsules surrounding tons of these tiny new viruses. Eventually the cell is so packed with new viruses that it lyses, it bursts, and those viruses are free to infect new cells in the body and continue to propagate themselves, which is bad. And your body knows this, and it reacts to it by creating antibodies. Your immune system recognizes the kind of virus that you are fighting, and it creates brand new antibodies that can fight that specific kind of virus. And if you're lucky, your body kicks its ass, it goes away, and you never get it again, which is true of lots and lots of different viral diseases. My favorite and least favorite kind of virus is the retrovirus. Retroviruses are really neat for what they do and how they do it. A retrovirus actually has the ability to insert its own DNA or RNA into the DNA of the cell that it's invading. These are things like AIDS or herpes or the human papillomavirus. This is why they're so hard to get rid of, and in some cases you have them forever once you get infected by them, because that cell now has viral DNA encoded into its own genome, and it builds viruses as it builds its own DNA. Every time that cell divides, it carries the new DNA with it, and those daughter cells then produce more retroviruses. It's really, really nasty. Hard to get rid of, but one of the really neat things about it is that if this happens to a germ cell, and it has in our past, we can tell by looking at some of our own non-coding DNA, junk DNA, and find what we call endogenous retroviruses, ERVs, segments of genetic code in our human genome that were inserted by retroviruses at some point in our evolutionary past. We are, at some estimates, between 4 and 5% virus, and that's pretty neat. Okay, now back to antibodies. Once you have those antibodies in your blood, they are there pretty much forever. The only way to get, say, chickenpox a second time is if you didn't have a very strong case the first time. I've known people who that happened to, and they didn't have enough antibodies, and so it managed to catch hold a second time. Or if you have a depressed immune system. Maybe you have HIV, maybe you're on chemo or radiation for cancer, which depresses your immune system and kills immune cells and antibodies. It's really the only way to get it again, and that's why most vaccines are great for just one-time use. Occasionally you need a booster, but if you get a polio vaccine, for example, you're good for the rest of your life. You're never going to get polio. Hey, because as it turns out, vaccines work pretty much the same way. A lot of vaccines use dead viruses. A virion is a virus particle, a single particle of virus. And then you break those down and you get the pieces of virions, the things that stimulate an immune response. and you put them in with some water and some other things, adjuvants, which is a thing that makes the immune response stronger while using fewer viral particles. You mix it in with some preservatives in some cases, and then shoot it into your system, and your body reacts to it exactly the same way it reacts to an actual viral infection, except you're not going to get infected because there aren't any live viruses in there, just the pieces that your body needs to build antibodies. Figuring out how the immune system fights off viruses was huge for human civilization, because we were then able to replicate it while putting people at very, very tiny risk. Any medical intervention comes with some amount of risk, but for most vaccines, you're looking at a 1 in a million, if that, chance of anything other than maybe sniffles for a couple of days or swelling around the injection site. Vaccines have probably saved more lives than just about any medical intervention in the world, especially when you look at the cost effectiveness of how cheap these things are to make, how quickly you can spit them out once you know what you're doing, and how effective they truly are. They're absolutely fantastic. Now, you might be wondering, well, you just said you get one shot and you're good for the rest of your life, unless maybe it's a tetanus booster or something. How come you need to get a flu shot every year? I see all these signs that say get a flu shot. Every year I have to get a new flu shot. Doesn't that mean that it doesn't work? No. It just means that unlike things like measles or smallpox, the flu virus mutates very, very quickly. The evolutionary rate of this particular virus is incredible. So every year we're facing a new strain with a different protein in its outer shell that causes a separate immune response from the one you got last year. Now, unlike things like smallpox, it changed very, very slowly, if at all, and has been eradicated from the face of the planet. Thank God, it's a horrible disease. You can't backplan, essentially, a flu vaccine because we don't know what next year's is going to be. But the World Health Organization and, say, the American Centers for Disease Control are really good at predicting that, to the point where they can predict and produce a flu vaccine for next year's flu cycle, for next year's strain, that is about 75% effective. And given the risk versus benefit ratio of this thing, where the chances of you having any serious side effect other than a couple of days of sniffles are almost non-existent, versus 75% protection against something that can kill you, get your flu shot, people. Because in 2011, according to the official numbers from the Centers for Disease Control in the United States, almost 54,000 people died from the flu or flu-related complications. Maybe you're thinking you're inflating that number if you add complications in, but these are people who would not have died of what eventually killed them had they not gotten the flu in the first place. Maybe it was pneumonia that was contracted because of influenza. Maybe it was a secondary infection that took hold while their immune system was busy fighting the flu, a bacterial infection or something that otherwise would have just been gone, would have been fine because the immune system could have dealt with it on its own. 54,000 people in the United States alone. We often tend to think of the flu as, oh, it's just the flu. I'll get it, a couple of weeks of puking and vomiting at worst, maybe some chills, and I'll be fine. But why risk that? Why even risk dealing with the couple of weeks of puking and vomiting and chills and sneezing and coughing and all that garbage? You have a 75% chance of not getting it this year if you take half an hour out of your day, $25 most places, even if you don't have insurance, to go sit for 3 seconds and have somebody inject a tiny needle into your deltoid muscle and make it pretty darn likely that you're not going to have to deal with those symptoms, and you will not be one of those 54,000 people who dies using some back-of-the-envelope number crunching like I did for the Ebola video a couple of weeks ago, and then using the updated death figures for Ebola in the United States. You're actually about 18,000 times more likely to die from influenza or complications thereof than you are to die of Ebola in the United States, and yet people are running out and buying gas masks and freaking out about Ebola at the same time as going, oh, I don't need a flu shot. And like I said, the way that a vaccine produces an immune response is exactly the way that an actual viral infection produces an immune response. You just don't have to suffer while it's happening. So get your flu shots, people. Don't listen to those folks who are like, oh, it's just a flu. You don't need a flu shot. Go get a flu shot. It almost can't possibly hurt you. It pretty much can only do something good. And even if we didn't quite predict it that well this year and you catch it anyway, you're really not out that much time or money or pain and suffering or anything like that. Anyway, I'm Don from Explosions Incorporated. This has been Constant Science. Have a good whatever.